We have been told that expensive photovoltaic solar panels are the only way to break free from the energy grid. But a curved mirror and a copper pipe have been outperforming them by 350% for over 150 years. It concentrates sunlight to a single point exceeding 500 degrees Fahrenheit. It converts that heat directly into home heating at 70% efficiency, and it costs under $50 to build from materials at any hardware store. Yet while the $1.3 trillion energy industry sells us $30,000 roof installations that discard 80% of every ray they receive, this technology sits proven in public records on 2 continents and remains almost completely unknown. So, what is it exactly? How does it work? And more importantly, why aren't any of us using this right now? To understand where this actually comes from, we have to go back to 1866 in a sun-filled courtyard in Tours, France, where a mathematics professor named Augustin Mouchot was facing a crisis the entire French government could not solve. France had no domestic coal supply. Every ton of fuel heating French homes and driving French industry was imported from Britain at a price the British set unilaterally. The government was terrified, and Mouchot was the only person asking the obvious question. He constructed a large parabolic mirror and aimed it at a single glass-covered boiler. The curved surface redirected every incoming ray of sunlight to one concentrated focal point. That point reached temperatures high enough to boil water instantly and drive a mechanical engine with no coal, no fire, and no payment to any foreign supplier. He demonstrated it publicly. It worked the first time and every time after. 12 years later, in 1878, he carried his machine to the World Expo in Paris, the largest gathering of engineers and government officials on Earth that year. He connected his solar concentrator to a refrigeration device and produced solid blocks of ice from nothing but sunlight and curved metal. Ice, in 1878, from sunlight alone. No fuel consumed, no grid required, no bill generated. The engineers in that crowd could not find a single flaw in the demonstration, and the men who were about to build fortunes from oil and coal were standing in that crowd, taking very careful note of everything they had just seen. The story moves to 1913, when American engineer Frank Shuman built the world's first large-scale solar thermal power station at Midi, Egypt, on the banks of the Nile. 5 parabolic mirror arrays, each spanning 200 feet, tracked the sun from dawn to dusk. They drove a 60-horsepower engine pumping 6,000 gallons of water per minute into surrounding farmland. The United States Army Corps of Engineers reviewed Shuman's design and confirmed its viability for large-scale deployment across the American Southwest. Then World War I began. Cheap oil flooded out of the Middle East, and Shuman's station was dismantled, his components scattered, and his name removed from every engineering curriculum that followed. And what engineers discovered when they measured exactly why Mouchot and Shuman's systems outperformed everything built to replace them is the part that changes everything. Because the physics happening at that focal point is something your $30,000 photovoltaic roof installation was specifically engineered to route around and never teach you directly. A standard solar panel converts sunlight into electricity through a photovoltaic chemical reaction. Physics places a hard ceiling on that process at roughly 20% efficiency under real operating conditions, meaning 80% of every ray hitting that expensive installation is converted into nothing useful whatsoever. Every hour, every clear day. A parabolic mirror does not attempt to convert light into electricity through chemistry. It concentrates light directly into heat through geometry. Every point on the curved surface is mathematically calculated to redirect incoming sunlight to a single focal line where the copper receiver pipe sits. That focal point exceeds 500 degrees Fahrenheit under direct sunlight. Water becomes high-pressure steam almost instantly. That steam carries heat directly into your home through ordinary insulated pipes, with 0 conversion losses. According to the National Renewable Energy Laboratory, parabolic trough concentrators achieve thermal efficiencies between 60 and 70% under standard conditions, more than 3 times the real-world output of any photovoltaic panel on the market today. The key variable is direct normal irradiance, the intensity of sunlight hitting the mirror surface perpendicularly. In most of the continental United States, that variable is high enough for 9 months of the year to make this system viable as a primary heating source. A simple insulated storage tank, filled with sand or pressurized water, holds that captured thermal energy for over 24 hours at 90% retention efficiency. No lithium batteries, no rare earth minerals, no degradation cycle. You charge the tank on a clear Tuesday afternoon and heat your home through a freezing Wednesday night, having burned nothing and paid nothing. The $1.3 trillion global energy industry generates its revenue through one mechanism above all others: recurring dependency, monthly billing, scheduled replacement. Every component of the photovoltaic solar industry is designed around that model. Panels that degrade on a manufacturer's timeline, inverters that need replacing every 10 years, battery banks that corrode through charge cycles and cost thousands to swap. You cannot patent the parabolic curve. It is a geometric truth older than any corporation on Earth. You cannot trademark the focal point of a mirror. You cannot meter sunlight and send a monthly invoice for the physics of reflection. And for an industry built entirely around recurring infrastructure payments, a $50 system that a homeowner builds in a weekend and owns permanently is not merely inconvenient. That is an existential threat to the entire revenue model. So they funded photovoltaic research instead. Systems requiring billion-dollar semiconductor fabrication plants. Systems depending on rare earth supply chains crossing 4 continents. Systems that keep you paying on their schedule indefinitely. Not because photovoltaic panels are better, because they can be sold and resold and serviced and replaced on a timeline that suits the manufacturer, not you. Here is exactly how to build it. You need 3 materials. First, polished aluminum reflective sheeting or mylar film, available at any hardware store for under $15. Second, a parabolic rib frame cut from 1/2-inch plywood. Third, a copper receiver pipe coated with black oxide spray paint. Step 1. Cut your parabolic ribs from 1/2-inch plywood using a printed template. A 4-foot wide mirror, 6 inches from center to focal line, is the proven backyard starting size. Step 2. Stretch your reflective sheeting tight across the ribs, pulling until the curve holds cleanly without wrinkles distorting the focal line. Step 3. Mount your black oxide coated copper pipe, 1-inch diameter, precisely at the focal line. Black oxide absorbs over 95% of concentrated heat, rather than reflecting it away. This coating is the step most builders skip, and it is the difference between a working system and a failed experiment. Step 4. Connect the pipe into a closed loop running into an insulated storage tank, minimum 20 gallons, positioned inside your home or in an insulated outbuilding. Step 5. Fill the loop with a water and propylene glycol mix, the same non-toxic food-safe antifreeze used in residential solar thermal systems to prevent freezing on cold nights. Total material cost, under $50 at any hardware or plumbing supply store. Daily running cost, $0. A $30,000 photovoltaic installation covers the same heating load this $50 system handles permanently with zero ongoing cost. For a test version, build a single 2-foot wide mirror panel first, connect it to a single coil of copper pipe, and measure the water temperature at the outlet after 30 minutes of direct sun. You will see 160 degrees Fahrenheit from a piece of plywood and $15 of mylar. To scale up, add mirror panels in a side-by-side array spaced 18 inches apart, each feeding into the same closed loop. 3 panels covers 40% of an average American home's heating load with zero fuel and zero ongoing cost. The Chinese imperial court documented concentrated solar heat as early as the 2nd century BC, using polished bronze mirrors to ignite ceremonial fires from sunlight alone. The Roman army carried polished shield arrays for the same purpose during desert campaigns. These were not accidents. They were engineered applications of the same geometric principle Mouchot formalized in 1866. A 2019 study published in the journal Renewable and Sustainable Energy Reviews confirmed that residential parabolic trough systems in U.S. climate zones 4 through 7, covering the majority of the American population, can displace between 30 and 50% of annual home heating demand with zero fuel input after installation. The physics have not changed since Shuman stood on the banks of the Nile in 1913. Zero fuel, zero grid dependency, zero monthly bill, a curved mirror, a copper pipe, and a law of physics that has been sitting in plain sight for 150 years. Subscribe and share this with someone who is still paying monthly for something the sun provides for free every single morning. If this gave you something real, pass it on.